So we now come to line and rotational symmetry. We have two types of symmetry that we need to look at. The first is line symmetry, which we want to think of as folding symmetry. Can you fold the thing in half, not just so that both halves are exactly the same shape, but so that they are actually, when they fold, on top of each other. So if we've got our triangle here, this triangle can be folded if I grab myself a nice other color. Down the middle here, if you fold it in half, this triangle will completely end up on top of the other one. So this triangle has one line of symmetry. This rhombus, on the other hand, if we fold it along this diagonal, it will be the same. Triangle on top and triangle on the bottom are the same. Sorry if my line's not quite straight. And if we fold it down this diagonal, it will also work. It has two lines of symmetry. Now just be aware and be careful with this, that if we have a rectangle, I'm trying to work out, let's actually go with a parallelogram. I can get the computer to draw me one of these. If we have a parallelogram, for example, though, it looks like it's nice and it will work. But if you fold it either this way, well, what you're actually going to end up with then this one, or something like that. It hasn't quite lined up. It'll be the same shape, but it won't line up. They'll be offset. They won't match. So that's the same with a rectangle. If we drew a rectangle, yes, it's got a line of symmetry this way, but if you go up the diagonal of a rectangle, you will find that this triangle, when it's redrawn, ends up looking like that. So these two triangles on this side are the same, but they don't line up. That is not symmetry. That is just happens to be that you've cut it into two congruent or exactly equal pieces. The other kind of symmetry we want to look at is rotational symmetry, which is a bit of a weird one. I don't think it actually gets kind of taught to as much effort in other countries in the world. But in Australia, we worry about rotational symmetry, and we talk about the order being the number of times the shape repeats when you spin it around. So if we spin our equilateral, our perfectly equal triangle around, and yes, we may not have used the word equilateral yet this year, but we will get to it. If we spin this around on its point, each of these corners will match every time. So there are 3 repetitions of that same shape. So we say it has a degree of 3. This kite, on the other hand, if you spin it around, you're only going to get fat end, skinny end kite. It'll never line up. It doesn't matter where you spin it, which point. So this just has no rotational symmetry. Now, to practice this, I want you guys to have a go at 403, just questions 3 and 4, because that's about rotational symmetry. And then there are 2 activities on Khan Academy, which I'll put instructions on how to get back into. Again, don't think you can ignore that, because I'm going to be setting a lot more Khan Academy activities over the next few weeks. And that will be very helpful to me while I have to do a lot of report setup and other things around the school.